In this video, we're going to be writing polynomial functions given the zeros of the polynomial function. And the first example says, write the polynomial function f of least degree that has a leading coefficient of 1 whose zeros are 2, 1 plus i, and 1 minus i. The first thing you have to realize, guys, is if they give you the zeros of the polynomial, you should be able to have be able to list the factors. So our factors are always going to be of the form x minus whatever the zero is. So when I have the factors of 2, 1 plus i, and 1 minus i, I know that the factors of f of x, or if I were to factor f of x, it would look like this. It would be x minus the 2. It would be x minus 1 plus i. And it would also be x minus 1 minus I. Just to kind of work backwards for a second, I mean, this makes sense if you think about it, because if you were solving this polynomial for its zeros, you'd have a 0 over here, and you would set each of these factors equal to 0, right? And if you set x minus 2 equal to 0, don't you get a 0 of 2, which is actually what we were given? If you set this factor equal to 0, you'd add 1 plus i to both sides, and you get a 0 of 1 plus i, which is the other factor. And the same goes for this guy. If you set x minus 1 minus i equal to 0 and added 1 minus i to both sides, you'd get x equals 1 minus i. So that's kind of why we set it up this way. We're really given the factors of the polynomial if we have its zeros. So I'm kind of starting from that premise. Let me erase all of that. All you have to do then, guys, I mean, if you have the factors, all we have to do is multiply these out. And I always recommend starting by trying to simplify these imaginary factors. And I'm going to begin that by distributing the negative. So this factor becomes x minus 1 minus i. This factor becomes x minus 1 plus i if you distribute that negative. Now don't forget, we also have the x minus 2 sitting over here. Now, if I multiply these guys out, you have to be very careful that you don't forget any steps. Forget any steps. So I'm going to do x times x, and I always like to mark what I'm multiplying with little arcs. So x times x is going to be my x squared. Then I have x times a negative 1, that's a minus x. And then I have x times an I, that's just going to be plus ix. I multiplied this first term x to every single term of that other polynomial, and I'm done. I'm going to move on to the negative 1 here. I'm going to do negative 1 times x to get minus 1x, or just minus x. Negative 1 times negative 1 is going to be a positive 1. And then negative 1 times a positive I is a minus I. I've multiplied the negative 1 to every term of the other polynomial, and I move on to the negative I factor, or negative I term, I should say. Negative I times x is going to be negative ix. Negative I times negative 1 is going to be plus I. And then negative I times positive I is minus I squared. And now don't forget, all of this has an x minus 2 that we still have to multiply to it. And it looks like it's really complicated, and it kind of is right now until we simplify it down. I'm going to try to find some like terms in there. I know I'm going to hold on to that x minus 2 for the moment. There is no other x squared term, so I'm going to copy down the x squared and cross that out. I'm done with it. Now I'm going to collect all of my x terms. I have a negative x here. I have another negative x, and those are the only x terms. I have a minus 2x, so I can cross those out. I have plus ix and minus ix. That's nice because those cancel. Notice I also have a minus I and a plus I. Those cancel. The other thing you have to realize, guys, hopefully you remember from chapter 5, I squared is really negative 1. So I have a plus 1 over here, see that? And then if I have minus I squared, I have minus negative 1, which is really plus 1. So I have 1 plus 1, that is 2. So after foiling all that out, if you do it right, the imaginary terms should all cancel out. I have to finish this off now by doing one more multiplication of x minus 2, that binomial, to the trinomial x squared minus 2x plus 2. And I'm going to begin by doing x times x squared to get x cubed. I'm going to do x times negative 2x to get negative 2x squared, and x times 2 to get positive 2x. Now I do negative 2 times x squared to get negative 2x squareds. Negative 2 times negative 2x is positive 4x. And then negative 2 times a positive 2 is a negative 4. I'm going to add the like terms. There is only one x cubed, so that's that. Negative 2x squared minus 2 more x squared is going to be a minus 4x squareds. 2x plus 4x is a plus 6x. And then I copy down the minus 4. This is my polynomial of least degree with leading coefficient of 1 that has the zeros of 2, 1 plus I, and 1 minus I. I'm going to do one more with you because these can be kind of tricky. So hopefully this will help. Let's take a look at example 2. Let's write a polynomial function f of least degree that has leading coefficient of 1 with zeros of 1, negative 1 plus I, or excuse me, negative 2 plus I, negative 2 minus I. So here we go. I know my factors. If I were to write, oops, I don't know why that just happened. So I know that my factors for f of x are going to be x minus 1, x minus the factor, or the 0 rather, negative 2 plus I, and the last factor is x minus the 0, negative 2 minus I. Now, what we have to do is take care of these imaginary factors. I'm going to distribute that negative, and I'm going to get x plus 2 minus I in that guy. And then if I distribute the negative here, I'm going to get x plus 2 plus I. Now I'm going to go ahead and multiply those two factors together. I'm going to just write the x minus 1 factor out there, and I'll start again the next step here. If we do that, x times x, x squared, x times 2 plus 2x, x times I plus ix. Moving on to the 2. 2 times x plus 2x, 2 times 2 plus 4, 2 times I plus 2i. And then I move on to the negative I. Negative I times x, negative ix. Oops. And then I'm going to have a negative I times a positive 2. That's going to be minus 2i. And then I'm going to have a negative I times a positive I. That's going to be minus I squared. Now it comes down to just adding some like terms and hopefully canceling some of these imaginary factors out. I only have the 1x squared, so that's going to stay. 2x and 2x. I have 4x. Cancel those guys. I have a plus ix and a minus ix. Those cancel. That's good news. I have a 2i and a negative 2i. Those cancel. And remember, this minus I squared is really minus negative 1, which is plus 1. And I have a 4 plus a 1 in this problem. That's going to be plus 5. Now I just have one more multiplication to take out. X times the x squared makes x cubed. X times 4x makes 4x squareds. And then x times 5 is 5x. I move on to distribute the negative 1. That's going to be minus x squared. Negative 1 times 4x is minus 4x. And negative 1 times a positive 5 is minus 5. Let's add the like terms, and I think we're done. X cubed. And then 4x squared minus x squared is going to be plus a 3x squareds. Let's cancel all those out so we know we're done. 5x minus 4x is just a nice plus x. Done with those guys. And then copy down the minus 5. And that is our function. The last thing I'm going to end the video with is going to be kind of interesting. What I want to do here is find the real zeros of a polynomial function by using our graphing calculator. So I'm going to bring up the graphing calculator, and what I'm going to do is I'm going to input the function in my equation editor. So I go to y equals, and I'm going to type in my x raised to the fourth, and then minus 5x raised to the third. Then I'm going to do plus 6x squared minus 20x, and then do plus 8. Once you have it in there, we want to try to graph this in a window where we can see the x-intercepts of the graph. So the shortcut, if you remember, is to hit the zoom button. And if you go to zoom, the sixth option is the standard window. I'm going to hit enter on the standard window, and this is what I get. Now, it's not a terrible picture because you can see we do get some of the graph here, but I cannot quite tell where these zeros are. I mean, I can maybe guesstimate where those are, but I'm going to adjust the window a little bit so we can see maybe the bottom of the graph and so on. So let's see if I can do that. The window, I'm going to make the y min go down a little bit further. Let's try like negative 40. We'll just kind of play with it a little bit here, and let's graph it from there. Okay, not too bad. It's a little bit better. Let's see if we can also get rid of some of the negative x values there. We don't need to see x mins that go all the way to negative 10. Let's actually just go maybe to negative 1. And let's rescale the y-axis to count by, let's say, 5s. So I'm going to change my window here and see, no, that's not too bad. Actually, and I might go a little bit further up on the y-axis, and you'll see y in a second. Let's go to the window one more time. My y-max, let's make 20, let's say. And I also noticed in that last graph, I don't think the x-intercept looked like it goes any further than about 5 or 6. So let's make it an x-max is 6. So that's a pretty good picture. It's not the greatest thing, but it looks kind of like the pictures that they give us in the actual example here, the snapshots. What we're going to do now is use the zero or the root feature of our calculator. I'm going to go ahead and actually carry that out on the calculator along with you. And I think we've done this before actually with our quadratic. So if you remember that, this is going to be very, very similar. To get there, you have to hit the second and then the trace button. This is the calculate menu. We have to go to the zero feature. That's also like the root feature, some calculators may say. So I'm going to hit enter on number 2. Now, what it's going to ask for is the left bound, the right bound, and then a guess. Let's first find the leftmost intercept. I'm going to move my arrow keys over until I can see my crosshairs, and you can see them now. My left bound, I have to make sure that I am left of that coordinate where the 0 seems to be. So I have to make sure I'm somewhere to the left of that point, and right now I currently am. So I'm going to hit enter, and then I'm going to use my right arrow button to go past that intercept and make sure I'm to the right of it. Oops, I don't know why it's still asking for the left bound. Let me make sure I hit enter. There we go. Now I'm going to go past it and or go past it to the right bound, and I'm going to hit enter. The guess, I have to go somewhere in between and hit enter. And it looks like I get about 0.44 if I round to 2 decimal places for my 0. So about 0.44. If I'm getting the other 0, I'm going to hit second, trace, choose 0 all over again. And now I'm going to use my right arrow button to get my cursor all the way over to the other side. I think a shortcut actually, if you can see, this is 1, 2, 3, 4, somewhere like 4.5. I might say I can just type in the number 4 and hit enter. And then my right bound, I can use my right arrow button if I want, but I have to make sure I go past it. I'm going to hit enter now. I'm definitely past it to the right. My guess, somewhere in between, hit enter, and I get about 4.56 it looks like. 4.56 for my 0 there. So I think that's all the calculator is really going to give us. So you can see that the real zeros are about 0.44 and 4.56. We are going to talk a little bit more about how to know what the other zeros are, but I just wanted to introduce to you guys at least how we can find the zeros by using the zero feature on your calculator, and we'll finish up the lesson more tomorrow. On the next page, I am going to ask that you try to do the following problems. So I'm going to give you a couple minutes. Why don't you try to do this following self-quiz, and I think your notes have the last page blank. Why not do it on the very back where you have that full page to do it? The first question is kind of like the first two that we did together in the video. Write the polynomial of least degree in standard form that has the following zeros, 2i and negative I. And number two, I just want you to use your graphing calculator to see if you can use the zero feature to find the real zeros of the function that I gave you. And we'll go over it tomorrow in class. Good luck.